The idea of smallest unit of matter, that is Parmanu, which combines to give Anu, was given by the Indian scientist Maharshi Kannad. The Greek philosopher Democritus called the Parmanu an atom. John Dalton gave the first systematic idea of the structure of atom. Hello everyone, welcome back to the channel. In today's video module, we are going to study Chapter 4 of ICSE Board Class 9 Structure of Atom and Chemical Bonding. So before to start the lesson, we will understand little bit about the introduction of this lesson. So basically, the idea of smallest unit of matter was first given by the Maharshi Kannad in 6th century BC in India. According to him, matter consisted of indestructible minute particle called Parmanus. Here, Parmanus means Param means ultimate and Anu means particle, now called atoms. A Parmanu does not exist in free state, rather it combines with other Parmanus to form a bigger particle, which is called as Anu. So now it is known as a molecule. There are different types of Parmanu, each of them exhibits specific properties. As the Greek philosopher Democritus called Parmanu an atom, which comes from the Greek word atomos, its meaning is indivisible. But the first scientific theory about the structure of matter was given by John Dalton in 1808. He considered atoms as indivisible particles that are the fundamental building blocks of matter. The existence of different types of matter is considered to be due to different types of atoms constituting them. The main postulate of Dalton theory that we will study now. So the first postulate was matter consists of very small and indivisible particles called atoms. Atoms are neither be created nor be destroyed. The atoms of an element are alike in all respects, but they differ from the atoms of other elements. Atoms of an element combines in small numbers to form molecule, as you can see in this picture. And atoms of one element combine with atoms of another element in a simple ratio to form molecule of compounds, and atoms are the smallest unit of matter that can take part in chemical reaction. The latest research on atom has proved that most of the postulates of Dalton atomic theory was incorrect, except that atoms take part in chemical reaction. One of the first indications that atoms consist of subatomic particles, that is, they are made up of charged particles, has been put forward by the studies of static electricity and the conditions under which electricity is conducted by different substances in 1833. Faraday showed that the flow of electricity is due to the flow of charged particles. G.J. Stoney in 1874 first suggested the name electron for this particle. However, it was J.J. Thomson who showed the existence of these charged particles and thus discovered electrons, which is negatively charged particles. E. Goldstein, a German physicist who discovered proton, positively charged particle in an atom. Later on, James Chadwick discovered neutrons. The electron, protons and neutrons are called the fundamental particles of an atom. These particles are building blocks of all atoms of an element. William Crooks, a British scientist, noted that gases are ordinarily poor conductors of electricity. However, when a high voltage charge from an induction coil is applied to tubes filled with gases at very low pressure, the gases becomes good conductor of electricity and begin to flow from cathode to anode in the form of rays. Since these rays originate from the negative plate, so that is the cathode, and travel from the cathode towards the anode, they are called cathode rays. Later, J.J. Thomson studied the characteristics and constituents of cathode rays, and the apparatus used by him is called discharge tube or a cathode ray tube. A discharge tube is hard glass tube fitted with two metal plates known as electrode, one of which is connected to the positive terminal of the battery and called anode, while the another electrode which is connected to negative terminal of the battery is called cathode. It has side tube through which gas can be pumped out by using a vacuum pump to create a vacuum. What was the property of cathode rays? Cathode rays travel always cathode to anode in a straight lines. They causes a greenish yellow fluorescence on a soda glass screen placed in the tube. They are affected by electric field. They are inflected towards the positive field and reflected from the negative field. This shows that they carry negative charge. When a beam of cathode rays is made to fall upon hard metallic targets like tungsten, X-ray are produced. They penetrate through matter. They cause ionization of the gas through which they pass. The ratio of charge to mass of the particle constituting cathode rays remains the same, irrespective of the nature of the gas taken and of the metal forming the cathode. They produce the shadow of an opaque object placed in their path and make a light of paddle with wheel rotate. Thomson concluded that cathode ray consists of negatively charged particles now called electrons. The name electron, meaning atom of negative electricity, was given by Johnson Stoney. These negatively charged particles are an integral part of all atoms. Electrons have both definite mass, definite electric charge, both of which are independent in nature of the gas in the discharge tube. Atoms are found to be electrically neutral, so they must contain in addition of in particles that are positively charged, such that the total negative charge of the electron is equal to the total positive charge. This realization led to the discovery of positively charged subatomic particle called proton. Goldstein noticed another set of rays traveling in the direction opposite to that of cathode rays, that is, from anode towards cathode. When a perforated cathode was used in above discharge tube, he called these rays as canal rays, since these rays passed through holes or canals in the cathode. These rays were named as positive ray or anode rays. Anode rays travel in a straight line. They consist of minute material particle and hence produce mechanical effects. They are made up of positively charged particles. Positive rays are deflected by electric and magnetic field, but in the direction opposite to that of cathode rays. This means that these rays consist of positively charged particles called the proton. These rays produce fluorescence on a zinc sulfide screen. In 1911, Lord Rutherford, a scientist from New Zealand, directed a stream of alpha particles toward a very thin gold foil. He selected a gold foil because he wanted as thin a layer as possible, and gold is the most malleable metal. He observed that most of the alpha particle passed straight through the foil. Some alpha particles were slightly deflected from their straight path. Very few alpha particles were either deflected by very large angles or completely bounced back. So according to this model, the atom contains large empty space. This is why most of the alpha particle pass through the metal foil without deviating from their path. There is a positively charged mass at the center of the atom is concentrated. Therefore, the nucleus is densest part of the atom. The electrically positive nature of the nucleus is supported by the fact that positively charged alpha particles approaching the nucleus get deflected. This proves that the nucleus contained protons. The size of nucleus is very small compared to the size of an atom. This is proved by the fact most of the alpha particle pass straight through the gold foil. The electrons revolve around the nucleus at the large distance from each other and from the nucleus. An atom as a whole is electrically neutral because the total positive charge of the nucleus is balanced by the total negative charge of the electrons. That is, number of proton and number of electron in an atom are equal. Electrons revolve around the nucleus in closed circular path called orbit. The force of attraction between the negatively charged particles electron and the positively charged nucleus is counterbalanced by the centrifugal force acquired by the revolving electrons. Drawback of Rutherford's atomic model. The comparison of electron with planets in the solar system is the main drawback of Rutherford's atomic model. According to the classical law of mechanics and electrodynamics, if an electrically charged particle is in motion, it inevitably radiates energy. Thus, an electron, when moving around the nucleus continually, should radiate energy, that is, loss energy. As a result, it should be gradually pulled towards the nucleus and end up colliding with it. This should result in the total collapse of the atom. If it was no, the atom should be highly unstable and hence matter would not exist in form that we know. However, we know that an atom is structurally stable. Thus, Rutherford's model failed to explain the stability of an atom. Bohr's atomic model in 1930, Niels Bohr, a Danish physicist, explained the cause of the stability of the atom a different manner. Main postulate of Bohr atomic model: electrons revolving around the nucleus are confined to certain fixed orbits called shell. Energy level such as each of the associated with fixed amount of energy while revolving around the nucleus in an orbit. An electron neither lose nor gain energy. An electron revolving in a particular orbit on gaining a certain amount of energy jumps to the next orbit and vice versa. Since each orbit is associated with fixed amount of energy, Bohr called it an energy level. For convenience, levels are labeled. For convenience, these energy levels are labeled K, L, M, N or first, second, third, fourth, etc. The orbit closest to nucleus in the K shell, it has least amount of energy and the electron present in it are called K electrons. Discovery of neutrons. By now, we know that an atom contains electron and proton and that the atomic mass of electron is negligible. Therefore, an atom of helium which contains 2 protons should have mass 2 AMU, but the atomic mass of helium, our atom, was found to be approximately 4 AMU. It was therefore proposed that in the nucleus of an atom there must be another particle. This particle should not possess any electrical charge and must be equal in the mass to the proton. In 1932, Chadwick discovered these particles by bombarding light nuclei like beryllium with alpha particles, helium nuclei. A neutron is a subatomic particle or fundamental particle of an atom with no charge and mass almost equal to the mass of proton, that is hydrogen atom. Neutron is denoted by N. This particle was not found to be deflected by any magnetic electric field, providing that it is electrically neutral. So hence now we understood Dalton's atomic theory and modern atomic theory. Dalton says atoms are indivisible particles, but modern atomic theory says atoms are divisible into subatomic particles like proton, electrons and neutrons. Dalton's atomic theory says atoms can neither be created nor destroyed. Atoms can be created according to modern atomic theory and destroyed by nuclear fusion or fission. Dalton's atomic theory says the atoms of an element are alike in all respects, but they differ from the atoms of other elements. The atom of modern atomic theory says the atoms of an element may not be alike in all respects, as is seen in the case of isotopes that we will study later. Atoms of elements combine in small whole numbers to form molecule, according to Dalton's atomic theory. But according to modern atomic theory, in the formation of organic compounds, the number can be very big, such as thousands. I hope you understood till here. We will continue the lesson 4B in next module. Till then, goodbye and take care. Thanks for watching.